Welcome everyone. Let's jump right into this explainer. Today, we are taking a much deeper look into space. We're going to journey from the cozy familiarity of Earth all the way out to the absolute deepest, most explosive corners of the universe. So if you've ever looked up at the night sky and just felt that profound sense of wonder, well, you are absolutely in the right place. Let's get started. Right off the bat, we've got to grapple with a seriously mind-bending question. Does space actually have an end? I mean, it's a frontier so incredibly massive that astrophysicists still can't definitively say where the edge is, or honestly, if an edge even exists at all. Just think about that for a second as we move forward. We are exploring a massive, perhaps entirely infinite expanse.
Okay, so here's our flight plan for today. We'll start with the vastness of space, then zoom in on our solar system, followed by Earth and the Moon. After that, we'll look at the life of stars and finally wrap up with the mystery of black holes.
So, Part 1, the vastness of space.
You know, when we look out beyond our own protective atmosphere, we're met with this wildly dynamic environment. It's not just emptiness. It's a chaotic, beautiful mix of planets, blazing stars, orbiting moons, icy comets streaking through the dark, and these absolutely massive galactic clusters. It's a busy place out there.
And the sheer scale? The math here is literally astronomical. The human brain can barely process it. The universe contains billions of galaxies, and inside every single one of those, millions, if not billions of stars. To put that into perspective, our own galaxy, the Milky Way, is just a single, tiny drop in this vast cosmic ocean.
All right, moving on to Part 2, our solar system.
Let's zoom in a bit. Our solar system is actually a highly structured environment. Right at the center sits the sun, and it acts as this anchor for a really delicate gravitational dance. You've got 8 planets, their moons, rocky asteroids, comets, and of course, dwarf planets like Pluto, all locked in this cosmic rhythm. And it is a seriously diverse planetary lineup. Mercury is hugging the sun, Venus is practically boiling, Earth is our little oasis, and Mars is the dusty red planet we all know. Then we hit the gas giants, massive Jupiter, Saturn with its famous rings, Uranus which literally rotates on its side, and finally the freezing, windy extremes of Neptune. Every single planet has that one defining trait making it completely unique. But, you know, absolutely none of those worlds would matter without the anchor. The sun is the ultimate powerhouse. Without this giant, glowing nuclear reactor sitting right at the center of our system, pumping out heat and light, well, life on our planet simply couldn't exist. It's the engine of everything. Let's bring it a little closer to home with Part 3, Earth and the Moon. So, what makes our home so incredibly rare? Earth is a cosmic anomaly, really. It's all because of these highly fragile, specific conditions that are just perfectly suited for survival. We've got liquid water, breathable oxygen, ideal temperatures, and a protective atmosphere. It really is an absolute oasis in the middle of what is otherwise a pretty lethal void.
And our exact experience of reality on this oasis is totally dictated by celestial mechanics. Earth travels its orbit around the sun, and that gives us our 365-day year. But at the exact same time, it's spinning on its axis, giving us our 24-hour day. These two simple movements literally author how you and I perceive time.
Of course, we share this whole journey with our closest neighbor, the Moon. It's Earth's natural satellite. It doesn't generate any light of its own, it's just reflecting the sun's rays. But here's the crazy part. Its weak gravity reaches all the way across space to physically pull on our oceans. That's what creates our tides, all from this rugged, cratered rock floating in the sky.
And that weak lunar gravity is something humanity has actually felt firsthand. 1969. During the Apollo 11 mission, Neil Armstrong made history, stepping out and becoming the very first human to walk on the moon. Just a towering, unforgettable achievement for our species.
Jumping back out into the deep now. Part 4, the life of stars. So what's actually powering the cosmos? Well, stars are essentially these massive nuclear engines. They are giant balls of hot gas sustaining continuous nuclear fusion. Our sun is just one of these reactors. It really only dominates our sky because it happens to be right in our immediate backyard compared to everything else in the galaxy. Now here's a fun fact. A star's appearance actually gives away its extreme physical state, and it's totally counterintuitive. The blazing blue stars, those are actually the hottest ones. Meanwhile, the red stars are the cooler ones. The color you see twinkling up in the night sky is quite literally a direct thermal map of that massive engine.
But these stellar engines don't live forever, and their life cycles are profoundly violent. Hot gas fuels that nuclear fusion for billions of years, but eventually, the most massive stars inevitably run out of fuel. And when they do, they detonate in these cataclysmic explosions called supernovas. What's left behind collapses into something incredibly dense, forming a neutron star or a black hole.
Which brings us to our final and arguably most fascinating chapter, Part 5, Mystery of Black Holes.
A black hole is, for all intents and purposes, the universe's ultimate trap. Born from the collapsing remains of those massive dead stars, it's a region in space where the gravity is so impossibly strong that absolutely nothing, not even light itself, can escape its pull once it crosses the threshold.
So you might be wondering, how do astrophysicists study something that is fundamentally invisible? Well, through pure deduction. Scientists have to observe how a black hole's immense gravity warps and violently whips around the nearby stars and gas. By watching all that intense chaos surrounding the invisible center, they can definitively prove the monster is actually there.
And if you thought these phenomena only existed in the super distant, far-off reaches of the cosmos, think again. Giant, supermassive black holes anchor the centers of most galaxies. And yes, that includes our very own Milky Way. This immense gravity well is spinning right in the very middle of our galactic home.
Which leaves us with a final awestruck thought to chew on today. What else is hiding in the dark center of our galaxy? Space is fiercely mysterious. It's relentlessly chaotic and endlessly massive. I really hope this explainer sparked your curiosity and maybe gave you a new perspective on the cosmos. Keep looking up, and I'll catch you on our next deep dive.